If you enjoy my videos, please check out my website at creationsciencefiction.com, where you'll find articles on creationism, science, and my blog. If you really enjoy what I'm doing, please consider becoming a contributor at the link in the video description.
So here's the Earth, right in the middle here. The tide would be like a big wave, you know, here's a bad wave, there you go, big wave, continually going around the world in a big circle around it. And so it's picking up dirt as it comes by, it's picking up a lot of material, and as it goes by, it's actually laying down some of that material as it passes by, as a layer. And then it comes around again, carrying more material and lays down stuff on top of it.
That is why you said that in Jordan we had the same kind of...
that rock right there, that's Tepete Sandstone. That rock is in Jordan. Whoa. That rock is in Israel. That rock makes up the entire northern half of Africa.
That was Nate Loper of Canyon Ministries. Nate is also the founder and president of Genesis Creation Science Institute, a small organization in Flagstaff, Arizona, and both organizations give tours for young Earth creationists in the Grand Canyon.
So it's been picked up. That same sandstone has been picked up, and that same material has been carried across the globe.
Can you give us some other examples? I know you mentioned the Appalachia area, that sediment being north of here.
Yeah.
Can you give us other examples of sediment moving?
Well, we talk about the Tepete Sandstone that we see here that's found not only the bottom of the Grand Canyon, but covers the entire continent of North America, making up all of North Africa, makes up parts of southern Israel and Jordan, and who knows how far it goes. You know, certain places we can't actually get down to very easily.
Well, none of that is true. The Tepete Sandstone is actually a local, regional formation. It never even really covered the entire region, as we see evidence of islands where the Tepete Sandstone tapers out in places. Geological studies of the Tepete Sandstone determine the depositional environment as tidal flats, beaches, and braided river systems based on the sediment textures, structures, and fossil types preserved. Evidence of these different depositional environments is actually evidence against it being laid down at a single time during a global flood. And it certainly didn't happen the way he described.
But the Redwall limestone, which is, that's what we see right up here. That big red cliff at the top, that Redwall limestone is covering the entire United States, all the way to the eastern coast. It's also found in England, and that same Redwall limestone is also part of the Himalayan mountain range. So that material has been carried even further than Tepete Sandstone. It's basically a worldwide distribution.
Wow.
And that's just utter nonsense. The Temple Butte Formation is actually evidence of stream bed erosion between the Redwall limestone and the Mauve limestone. Geological studies of the Redwall limestone indicate different environments when different parts of the Redwall limestone were deposited. Dolomite, for instance, was formed under shoal conditions. Other areas show evidence of being formed under turbulent waves, and even others show that it was formed in a very calm sea. These shallow seas would have been teeming with life, and we can map out where it started and stopped again because it wasn't continuous. It is not a worldwide deposit like he says. Now comes the big experiment along the banks of the Colorado River and the Grand Canyon. This is creation science in action. That's a couple minutes long, but it's well worth watching.
Well, to take some water and just kind of slowly pour it in here. Doesn't have to be all that fast. All right, so grab buckets and you guys can jump in and participate.
Did you?
Go for it.
Go ahead. I'm so sorry.
Go ahead and fill it in. And then don't pour it too
This is
fast.
supposed to represent a lake that was left over after Noah's
Now
flood.
watch this one spillway. All right, that's good. Let it spill through a while. But starting from nothing, keep watching. All right, Baker. Yeah, put in more water. Keep going. And keep watching downstream here too. This is where it gets really fun too. We have a nick point coming down here, so it's there we go. Fun with physics. We'll breach our wall there on the side. But look at how much this is
Oh, look at
eroding
this.
down here even. And look at this.
Got more speed. Get a little velocity and a little bit of debris in there, and it'll move some.
Yeah.
Or add 6 million years.
Now look at what it's carving downstream here. This whole thing.
That is really pretty impressive. That's so it's the speed and the density of the water.
Yeah.
Kind of starting to look like the Grand Canyon.
Really?
So here's kind of a mini representation because you can already see, wait a minute, look at what it's doing here. So if we had a water source like that up there, I mean this was completely just flat and smooth right here just a few seconds ago, right?
Well, there it is. Looks nothing like the Grand Canyon. Has no features of the Grand Canyon. Let's compare it. Nope. I don't see 2 straight lines there.
And so if you're pouring a massive amount of water, we're talking about a huge amount of water pouring down through here.
Well, it doesn't look at all like this to me. I don't know how you'd get one of these horseshoe bends out of a straight line like that. This is evidence of erosion over millions of years. So his presentation was full of misinformation, his experiment failed, yet his audience just seems to eat it up.
So hopefully this will help kind of illustrate a little bit of what I was talking about.
How could anyone be standing in the Grand Canyon, look around them, look at the little experiment that he did, and say, oh yeah, that explains this?